So today we'll be expanding on what we learned yesterday, which was how to write the electron configuration for atoms. Who can remember for the first 20 elements, what is the general electron configuration rule? Great, 2882. Is this the electron configuration for all of the first 20 elements? So the exact electron configuration? No, okay. So how do we use it? Right, so we allocate the number of electrons an atom has into each section, starting from the first two until we've allocated all of the electrons an atom has. So if lithium has 3 electrons, what's the electron configuration for lithium? Awesome, 2, 1. What we're going to look at today is what happens to these electron configurations when atoms react with other atoms. First, I want us to have a look at valence electrons. Now, these are the electrons in the outermost shell. These interact with other atoms and are responsible for an atom's chemical properties. As we discovered last lesson, elements in the same group on the periodic table have the same number of electrons in their outermost shell, so the same number of valence electrons. Who recalls, are the groups of the periodic table the columns or are they the rows? Nice one. So each element in the same column has the same number of electrons in its outermost shell. Quick challenge question. Does each element in the same group have the same number of shells? Good thinking. They mustn't if they've got more protons, because that must mean they have more electrons too. So this is an example here of lithium. How many valence electrons does it have? Beautiful, just the one, this one here. And our groups are along the top. So these electron shells are most stable when they're full. Atoms want to do what they can to achieve this. So if an atom only has a few valence electrons, they'll want to get rid of these because it's much easier to just let them go than it is to try and fill in all the missing electrons to get a full shell. Who can tell me, are electrons positively charged or negatively charged? Perfect, they're negatively charged. So if an atom is getting rid of some of their electrons, but it's keeping its protons, do we think the atom will be balanced or unbalanced? Great, unbalanced. And if it's got less electrons, so less negative charges, will it be negative or positive overall? Nice work, it'll be positive. It's the opposite for atoms that have a few electrons or who are a few electrons short of a full shell. It's much easier for them to just gain electrons to get a full shell than it is for them to get rid of all of their outer shell electrons. If they're gaining electrons, are they going to be positive or negative overall? Great, they'll be negative because they've got more negative charges because of more electrons. When atoms are unbalanced, they're called ions. Positive ions are called cations and negative ions are called anions. Quick quiz, what are positive ions called? Beautiful, cations. And what are negative ions called? Anions, fantastic. Let's have a look at what happens to lithium. How many valence electrons does lithium have? Beautiful, it's got 1. So do we think it will prefer to give away this 1 electron, or do we think it would prefer to gain 7 electrons to fill the 8 spots in its outer shell? Exactly, it will want to get rid of the single electron. So will it have an overall positive or a negative charge? Beauty, a positive charge, because it's getting rid of an extra negative charge, so it'll have more positive charges in its protons overall. Now let's think about the electron configuration. What's lithium's normal electron configuration? 2, 1, that's right. If it's losing the outer electron, what will its new electron configuration be if it's just an ion? Great, just 2. I want you to have a go at the ion charge and electron configuration for a fluorine ion. It's got 7 electrons in its outer shell. So first you'll need to decide if it will gain or lose electrons. Then you need to work out if it will have a positive or a negative charge. And then you need to decide what its new electron configuration will be. We'll come back as a group and go through it together after we've had a go individually.